Hey guys, so I want to go over this test review with you. This is for Integrated Math 2. And it's just going to go through what we've covered. The part 2 on today's team test is something you still want to go over. So being able to find the slope between 2 points is a key one. Looking at the triangle sum is a key one. And just being able to understand those types of problems. So look those over. Team test is posted for you guys to review. It will be there for you guys for the duration. And for you guys to keep on looking over until tomorrow's test. It's 4:35 right now. I'm still at the school. I got done with practice about an hour ago. I made my other video that's posted for my pre-calculus students. So I'm hopefully going to cut this short. I'm going to show a lot of shortcuts for these just because I want to keep this video down for you. But if you need to always pause it and going back, you guys can. Looking at this first one, these are just multiple choice questions. We should be able to talk about these. If a system of linear equations has infinitely many solutions, then the graph of the system will look like what? So when we graph these two lines that represent the system, what is it going to look like? A, intersecting lines, the same line, perpendicular lines, or parallel lines. If we have infinitely many solutions, that means we're going to have both lines line up on each other. So that means we're going to have the same line. So our first one's going to be C. If the result when solving a system or elimination or substitution is 4 is equal to 4, so whenever we solve this out and we get an answer like 4 is equal to 4, what do we know about it? What do we know about the graph? What is that going to tell us? Is it a true or false solution? Do we have an x equal to a value or a y equal to a value? In this case, we don't have either x or y in there. It is still a true statement. So in this case, we say we have infinitely many. We have infinitely many choices we can choose because no matter what we plug in, it's going to give us the same answer, okay? Coming up with this next one, if a no solution to a system of linear equations in the graph of the system. Your team test had this, so when do we know when we don't have any solutions? One key thing is when we have two numbers that when we solve out using elimination or substitution, they're incorrect. It would be like 2 is equal to 4. That's a false statement. In our graphs that we're getting here, we're getting the y-intercept to be different, the same slope to be the same. In this case, that would be D, parallel lines. So check those out, look those over, look over your notes. We talked about them. It should be on one of those handout sheets that I've given you, so please take your time and do those. Okay, when solving a system by elimination or substitution, what does the solution represent? Sorry, this is kind of blown up. Parallel lines, the slope of the line, the point of the intersecting graph of the system, or just the answer. In this case, it's going to be C, the intersecting lines of it, the intersecting portions of the graph. So that is all we want to be able to see here. Okay. The next one we want to be able to do is actually solve these algebraically. I'm going to kind of go through these fairly fast. These would represent some of our substitution types of portion problems. You also want to be able to know how to solve these. This is definitely integrated math 1 material, multi-step equations. Do not call Mexico after midnight. So if you need to, pause the video and practice these, see what you guys get, and we'll go ahead and do these. So pause it, and then we'll see what happens. So we have 3x minus 12 is equal to 2x plus 6. I'm going to subtract 2x to get negative 2 on both sides. Subtracting it, we're going to get 2. And then I'm going to add 12 to both sides, and I'm going to get x is equal to 18. Okay, done with that. Again, I'm showing you guys shorter steps, so I'm hoping you guys are getting these. The next one to my right, I want to be able to distribute first. This is 18x minus 5 is equal to 18x minus 6. I'm going to move my values over, negative 18 on both sides. When we solve out, negative 5, we're going to drop down, we're going to get negative 6. Now, is this a solution? Did you do something wrong? No. This would follow underneath our no solution set, meaning no matter how we graph it, it's not going to look the same. So don't worry if you get something like this. It is acceptable. It is possible to not have that. Another way to show, I believe we're going to show this, I can't remember, but you can put no solution. Okay, I'll look at your guys' notes and we can go from there. Okay, so practice those, see what you guys get. The next one we're going to go ahead and do is looking at graphing. Graphing is another key part that we look in here. You got to be able to look at the slope and intercept form that we've talked about. These are two slope-intercept forms. So I'm going to go ahead and look at this first one, -2, which is going down my y-intercept, and then I'm going to use my slope. This is 1, this is 2, which I'm going to go up 2 over 3, back 3 down 2. So this is going to give me my slope here. Again, try to be as accurate as you possibly can to make a better graph. This one I'm going to go up 2, and then this will give us up 1, or up 1 over 2. Did I make a mistake? I think I made a mistake. I'm sorry, guys. Let me clear that. Let me just redo it. Down -2, sorry. And then we're going to go up 3, 1, 2, 3, 1, 2. Sorry. Made a boo-boo. Okay. Next one we're going to do is we're going to go up 2. And then up 2 over 1, up 2 over 1. These are intersecting here. These are not parallel. Our solution to our set is going to be the intersecting line there, which happens to be 4, 4. So make sure you guys are checking those out. Okay, apologies for the first one. Again, graph the slope, or graph the intercept, graph the slope. Graph the intercept, graph the slope. Okay, we always want to write it in ordered pair, as in x, y, so make sure you guys are doing those. There's another type. One thing that we should automatically be seeing here is they look very similar. They look very similar, like the same graph. Now, what happened here? It's not showing up. Reset this. Okay, we have our two graphs here. One thing that we're seeing here automatically is I know that I have the same slope, right? -7 over 3 is the same slope. So I'm already suspecting something, whether it be a no solution or many solution. These two are both the same. These are the same. But the back part we have is different. Okay, this would mean that we'd have no solution. And the way that we can look at that is just by graphing. I'm going to go down 3, down 7 over 3, or back 3 up 7. There's our first one here. Just going to go down there. We had to go up 1, so up 1, back 7, 5, 6, 7. We get a line that goes down here. These are two non-intersecting lines. Sorry, my graph is kind of off, but you guys will be able to use it kind of correctly because I want to give you guys opportunity. Ooh. Okay. Again, graphing solutions. One thing we want to be able to see here is being able to rewrite them in terms of as we want to be able to develop these. This is in standard form. We talked about using -a over b for our slope. And our intercept is going to be c over b. So I'm going to do them simultaneously, hopefully. This is a, this is b, and this is c. So my first equation here, I'm going to get -a over b, which happens to be -1. So -3 over -1 is just going to be 3 over 1. And then my intercept is going to be -2 over -1, or just 2. So my first one being 3 and +2. I'm going to go up 2 and 3 over 1. If we do the bottom one, again, this is A, B, and C. A in this case is going to be our 2, so we're going to have -a over B, which is -2 over +1, or just -2. And then my B over C, or my C over B, sorry, is going to be -3 over 1, right? We can represent this by 1 here, or just -3. So I'm going to go down 3 to start this one up, and then I'm going to go down 2 over 1, back 2 over 1 is going to give us 1 here. So this actually does have a nice solution because we have a different intercept. It's going to happen to be -1, -1. So please use those. You definitely want to be able to understand how to use those and try those out. Okay. We're going to finish this up here. We're going to do one substitution, one elimination. And we'll be okay. Let me see again. I don't know what happened to my. This keeps on going crazy on me. Sorry about this. There it is. So let's go ahead and graph my line. And we're going to do this one, and then we're going to do another small graphing, or sorry, word problem for you guys, just to practice. We always talk about practicing those for our word problem in our charts. We want to use substitution, and it's screaming out for us to use substitution. My isolated variable is here, so I'm going to take this and plug it in. I'm going to get -2 times my quantity 4y minus 3 plus 3y is equal to 11. Now this is just like the problems we solved before. You got to be able to simplify out. So -8y plus 6 plus 3y is equal to 11. So we're going to go ahead and solve this. We're going to combine like terms now. It's going to give me -5y plus 6 is equal to 11. -5y is going to be equal to 5. Y is going to be equal to -1. So again, I'm not showing all the steps. I want you guys to be able to do those. Plug it into either equation will work, because we've got to be able to find the x value. So I want to plug it into the bottom one. X is going to be equal to 4 times -1 minus 3. X is going to be equal to -4 minus 3. X is going to be equal to -7. So my solutions to this set will be -7, comma, -1. And so make sure you guys are practicing those. Substitution you'll need to do, elimination you'll need to do, graphing you'll need to do. And then you get to choose. You get to choose your types. Okay, you'll have a word problem on there as well, so please beware. Okay, I'm going to skip the substitution. If you want to practice that one, go for it. Elimination is also a good one here. I want to do 2 eliminations, one that we don't have to arrange, one that we do. This first one, we want to make sure that our numbers are stacked. In this case, our x's are good, our y's are good, and our whole numbers are good. We can now add up our rows, because I already know that the y's are going to cancel out to each other. This will give me 2x is equal to 2. X is going to be equal to 1, so it's going to look out really nice. I'm not done yet. I got to take this and plug it back in. I like the one on top only because it has really no multiplication numbers in it. So -x plus y is equal to -2. I'm going to plug that x in to give me -1 plus y is equal to -2. Adding 1 to both sides will give us y is equal to, sorry, I'm going to make that plus, -1. Solution sets for this first one is going to be 1 comma -1. Okay. That's all we want to be able to see with that. So I'm trying to take the time. It's 4:48. So for another 5 more minutes with this. Here's our other one that we want to be able to change up. This one's slightly harder only because we don't have really the x or y's that are opposites of each other. So we want to be able to force one of them to be. The x's or y in this case depends on what you want to be able to use. I'm just going to go with my x's just for traditional sake. To find the opposite, I'm going to make the top multiplied by -2. Rewrite this down below. -2x minus 2y. So I'm going to distribute these to each of my terms is equal to 2. I'm forcing them to be opposite, so I'm going to go and add them. These are going to cancel. I'm going to be left with y is equal to 2. So look how nice that comes out. I'm not done yet. I got to be able to take my value. I'm going to go ahead and plug it into the one on top. It's just easier for me to do. I'm going to get x plus y is equal to -1. X plus 2 is equal to -1. Subtracting out 2, we're going to get -3. Yes, -3. Always mess up on my negatives sometimes, so be aware of that. That is our solution for those. So I'm hoping you guys have seen them. Again, you can always pause the video and go back. You can always pause it, see how I did it, see where I got my values, always plug back, okay? One more thing I want to let you guys know is I'll be here on tomorrow morning around 5:40. I know you guys won't be here this morning, but you can always be here. I'll be here. I'll help you guys out if you need to. So I'm here for you. Ask questions. Let's get it going. I'll throw some problems up there if you want me to. And we'll help you guys out as much as we can, okay? We'll help you guys out as much as we can. So let's go ahead and clear this. Let's work on our last problem here. So word problems. This is one of the ones that we talked about the most, especially the times that we've seen. I want you guys to get used to them and just start seeing them. I always told you about the box to create with this. Remember how we talked about it? Definitely want to read the context of the problem to begin with. Matt and Todd are selling fruit for a fundraiser. Customers can buy small or large orange boxes. So in this case, we have small and a large. We want to find out the cost of them automatically. Matt sold 3 small, 14 large for a total of 203. Todd sold 11 and 11 large boxes for 220. We want to find the cost of each one of those boxes and how much they each were. So I'm going to create my box in here. Some of you guys can automatically come up with this idea of being able to just create the equations, and that's what we're hoping for. I want you guys to be able to get there and not have to worry about filling out this chart every time. So in this first one, we're going to say small box, large box with the capital L. Matt is going to be on the top, and then Todd is going to be on the other side. Okay, we have 3S for 3 small, 14 for large, and then he sold it for 203. Todd was 11 small, 11 large boxes for 220. I think it's going to be really, really big numbers, but it's okay. We'll set up for it. I'll do the math for it, so it's okay. So we have our 3S plus 11S is equal to 203. The word problem you're going to see on tomorrow's is going to be a little bit more lenient. So don't freak out over this. I've already made a boo-boo here. It'll be L. And then we also have, so that's writing this all wrong. This would be 14L is equal to 203. Then we have the other one as 11L is equal to 220. So again, this is a lot right here. We want to be able to find opposites, and one of the opposites that you can't really think of is what goes into 11. And I think for 3, it would be multiplying the top by a negative 11, which is a big value. It's okay, we can still do it. And the bottom one by 3 to get rid of that, make 33 as opposite. So we have to change up this whole problem. It's going to take us a while. So negative 33s plus, I'm going to take out my calculator. This will be 11 times 14, or negative 11 times 14, which will give me a negative 154L. 203 times negative 11 is going to give me negative 2,233. It's okay, we can still do it. I know you guys are like, oh my god, Mr. Aguilar, these are so big. It's okay. We're going to figure these out together. I'm just distributing the bottom term as well. This will give me 660 on the bottom. We force the top to be the opposites, or the S's to be opposites, so we know that the S's are going to go away. 154 minus 33, or finding the opposite, is going to give us 121L. And then taking 660 away from 1773 is going to be what's there. And look at that. When we divide out both sides by 121, we are going to get L is equal to 13. I didn't know if that was going to come out, but it came out pretty nice. So I know that my large box of oranges cost 13 bucks for us. So, it's a lot of work. It's okay. I'm going to go ahead and plug it back into the one down below here. We got to be able to find out how much a small box was. So 11S plus 11 times 13 is equal to 220. We want to find out what 11 times 13 is. Okay, so we're going to get 11S plus 143 is going to be equal to 220. We're going to subtract that 143 And we're going to get 220 minus 143 is going to be, how nice it's going to work out, 77. So dividing this out, we're going to get 7. Small box of oranges costs $7. Large box costs 13. So it's one way we can definitely do that. So this kind of concludes the review for you guys. If you guys want to look over old problems, you guys have the old quizzes and tests, or not the old quizzes, but you guys have the old homeworks for you guys. Use the team test to help you guys solve those out. That's kind of very, very important. I'm just looking to see what else I need to cover with you guys. But you also want to make sure that you guys are covering part 2 of the equations, knowing how to rearrange your terms to slope, intercept, and standard form, and then also being aware of how everything kind of goes into play. That is rearranging your terms for substitution and graphing. So graphing, substitution, elimination, word problems, and then everything else will fill in. Again, good luck. This will be posted in a couple minutes. It's 4 minutes to 5. Getting that to you guys right now. You guys have a good evening. Any questions, feel free to email me. If not, I'll be here tomorrow morning early. We'll have extra problems if you guys want to go over them with you guys. So you guys have a good night. Take care, guys. Be safe. See you guys tomorrow morning.